A very good morning to all of you. Today we are discussing one of the important topic, that is reactive intermediates. As we have already discussed about some of the reactive intermediates, carbocation, carbanion, or free radicals. So these carbenes are also the short-lived intermediates formed during the chemical reactions. The chemical reaction carbene is actually the chemical species in which carbon atom is bonded to two monovalent atoms and also had two non-bonding electrons. So in carbene you will see here that the carbon atom, it is a having two monovalent bonded to two monovalent atoms, as well as having two unshared pair of electrons or two non-bonding electrons. Clear? So overall the number of electrons present in this carbene is 6. So there is a deficiency, it is a deficit of there is a deficiency of two electrons in order to complete its octet. So in order to become stable, it needs two electrons to complete its octet. So carbenes are electron deficient species. So like carbocations and carbenes are also electron deficient species. So how this carbene, let us see the examples of here. For example, we have methylene carbon, we have dichlorocarbene, where the monovalent atoms are hydrogen here and the monovalent atoms are here chlorine, two chlorine atoms, and a lone pair of electron or non-bonding of electron is present at this carbon. Clear? So how the generation of carbene, how the carbenes can be generated. First step is by pyrolysis or photolysis of diazomethane. Pyro means heat or photolysis means light. Photo means light. To pyro, by means of by applying the heat to the diazomethane or in presence of light, the diazomethane or ketenes gives the carbenes. Clear? So let us see here one by one. Let us see the how the diazomethane gives methylene carbene. It is how carbene is formed from this diazomethane. So this is the diazomethane. Diazo means there are two nitrogen atoms attached to this methyl group. That's why it's called as a diazomethane. Azo means nitrogen. So here we will see that there is a transfer of electrons as a result of which this positive. Here we will see the how this carbene gets formed. Nitrogen from the lone pair of electrons get shifted towards this. As a result of it, this pi bond gets shifted to this carbon atom. As you will see here that this carbon is carrying negative charge and this nitrogen gets positive charge. Then after this, due to heterolysis of there's a heterolysis takes place between carbon and nitrogen. Due to the heterolysis of this covalent bond, you will see here that the methyl carbene is formed in presence of light or in presence of heat. So and second product, the byproduct is formed, that's called as a nitrogen gas, is also formed during the chemical reaction. So you have seen that how the methyl carbene have been generated from the diazomethane. Clear? Similarly, you can also prepare the methylene carbenes from ketenes. Ketenes are actually CH double bond C double bond O. Here the shift of the electrons takes place from here. This is the carbon monoxide is formed here with the formation of this methylene carbene. Methylene carbene, clear? It's having the two unpaired electrons and two monovalent atoms are attached to this carbon atom. So this is how we have seen how the carbene can be prepared from diazomethane. Similarly, the carbenes can also be prepared from by the action of sodium hydroxide on chloroform. One of the important reaction, well-known reaction, Raymond-Taylor reaction in which the reactive intermediates carbenes are formed, which acts as a electrophilic substitution which acts as electrophile because these are electron deficient. So this they will act as a electrophile in that reaction. So we will see how this can be generated from this in presence of base and chloroform. This chloroform in presence of base gives this trichlorocarbene, but this further the one of the chlorine molecule gets eliminated here. As a result, this forms a dichlorocarbene, okay, which acts as electrophile in Raman-Teimer reaction. Clear? You will study in 12th class. So now let us see what are the different types of carbene. So from the above you have seen how the carbenes can be generated. Carbenes are simply in which carbon atom is bonded to two monovalent atoms, and the carbon is carrying lone pair of electron, that is unshared pair of electrons are present at this carbon atom. Clear? So this is carbene. This is just like as other chemical species, it is also electron deficient species. So let us see, there are different types of carbenes here. So one of them is a singlet carbene and another is a triplet carbene. So singlet carbene you can represent this can be represented as CH2 carbon is attached to two monovalent atoms with electron pair, that is one electron in both the electrons are present in the same orbital on the same orbital with opposite spin. Clear? So here see carbon in this singlet carbene, carbon atom is actually sp2 hybridized. Two out of the three sp2 hybrid orbitals, out of the three hybrid orbitals, two are involved in the formation of sigma bond with this monovalent atom. Clearly, two orbitals are in the formation of covalent bond, while the third hybrid orbital contains a pair of electrons. Here this is a hybrid orbital. So you know that in hybridization there are, when sp2, in case of sp2 hybridization, so there are three orbitals are formed actually. So two orbitals form the bonds, hybrid orbitals form the bond, covalent bond with these monovalent hydrogen atoms or any of the monovalent atom, and rest one hybrid orbital is carrying the pair of electrons with opposite spin. So this the pair of electrons are present in the same orbital. Clear? And another orbital which is unhybridized orbital, that is unhybridized orbital which is perpendicular to this hybridized orbitals remain vacant. So this is a vacant unhybridized orbital. Clear? So here this does not contain any electrons, though in case of singlet carbene both the electrons are present in the same orbital of the same orbital. Clear? So one important thing is that the singlet carbene is actually bent in shape. You are seeing that the hydrogen atom, because of the presence of this pair of electrons, there occur the bond pair and lone pair repulsion or bond pair lone pair repulsion, due to which this gets somehow banded shape like this. It gets like this shape, is a banded shape because of the bond pair lone pair repulsion. Clear? Similarly, second type of the carbene is a triplet carbene. Triplet carbene can be represented by this, that is CH2 with two electrons with having the same spin, both clockwise spin. So actually the two electrons are not present in the same orbital, they are present in the two different orbitals. So let us see the orbital picture of the triplet carbene. Here here we will see the orbital picture of the triplet carbene. Actually the carbon atom is sp hybridized. So aspirated, the two hybrid orbitals are involved in two covalent bond formation, while the two unhybridized orbitals have one electron each. So in case of singlet carbene, we have seen that two hybrid orbitals are involved in the sigma bond formation with the monovalent atoms clearly. But in case of triplet carbene, and one hybrid orbital containing the lone pair of electrons, that one hybrid orbital containing the and pair of electrons in it. So both the electrons were present in the same orbital, just like as this in case of singlet carbene. But in case of triplet carbene, this is not the case. It is s carbon is sp hybridized. So two hybrid orbitals are formed, which forms the carbon sigma bond with this hydrogen. Clear? So two carbon hydrogen sigma bonds are formed, and in this carbon there remains, you know that a carbon has four valency, as a result of which there remains two unhybridized orbitals. The two unhybridized orbitals, in case of triplet carbene, these two unhybridized orbitals contain single electrons each. For example, here is one orbital, there is one orbital. So one orbital is, this is a orbitals which are in which a carbon atom forms a hydrogen bond, forms a covalent bond with this hydrogen. So this, the two electrons are present here in the different orbitals with same spin. Clear? The two electrons are present in two different orbitals, but these orbitals are not hybridized. These are unhybridized orbitals, which does the unhybridized orbitals are those orbitals which does not have taking place, which does not have role in hybridization. They are actually, they remain unhybridized during the hybridization process. As a result, these are called unhybridized orbitals. So these electrons are present in these unhybridized orbitals, but the electrons are not putting together. They are present in two separate unhybridized orbitals. Clear? So it can be represented as like this. You have seen here. So the carbon atom is sp hybridized. The two hybridized orbitals are involved in two covalent bond formation clearly, while the two unhybridized orbitals have one electron each with parallel spin. So as I have shown you the picture how these two electrons are present in two different unhybridized orbitals. So it is also regarded as a biradical. This triplet carbene is also called as a biradical. So one of the important thing is, you must note here that this triplet carbene is more stable as compared to that of the singlet carbene. Although although it seems that the singlet carbene should be more stable, but in actual practice triplet carbene is more stable as compared to the singlet carbene, because in case of triplet carbene the electrons are present in two different orbitals, clear, and hybridized orbitals. And in case of singlet carbene, the electrons are present in same orbital, clear. So when the two electrons present in the same orbital, due to this electron repulsion, there occurs some instability as compared to that of this carbon, where the electrons are present in two different orbitals. As a result of which there does not occur any of the electronic repulsion. So there is no electronic repulsion in case of triplet carbene, where there is electronic repulsion in case of singlet carbene. So in practice triplet carbene is more stable than that of the singlet carbene. Clear? So you will see here the triplet carbene in which electrons occupy different orbitals are more stable than singlet carbene. Clear? So this is we have seen how the triplet carbene is formed, and what is the orbital picture of the triplet carbene or singlet carbene. Clear? So in case of triplet carbene, it is more stable as compared to that of singlet carbene. Similarly, you will here see the another type of the reactive intermediate, that is called as a nitrenes. A chemical species in which nitrogen atom is bonded to a monovalent atom or a group with two lone pair of electrons on nitrogen atom. So this is like that of the carbene. It is having also the singlet carbene or singlet nitrene or triplet nitrene. But actually here the case, the nitrene actually, the carbon atom, sorry, the nitrogen atom, these are called as nitrenes because nitrogen atom is here carrying the two unshared pair of electrons. Two unshared pair of electrons are present at this at this nitrogen, and it is also bonded to one of the monovalent atom, one of the group atom or monovalent atom or group of atom. So here for example it is CH3 here. So it means that because nitrogen, it is bonded with only with one of the, or one of the monovalent atom or group of atoms. So how this nitrene is formed. You will see here that this called as a methyl nitrene when there is a only CH3 group is attached to this nitrogen atom. The generation of the nitrene will be taking place as by thermolysis of alkyl azide. You can prepare the nitrene by heating the alkyl azide. So here is how you will for how the nitrene can be generated from the alkyl azides. So here is a case. Here the first case is that when the alkyl azide is heated, clear. So it forms, you will see here that it forms the nitrene, and nitrogen gas gets released here. So it is a movement of electrons from here. The shifting of electrons takes place as a result of which nitrogen triple bond nitrogen is formed, and this bond gets cleaved further in presence of, actually here the intermediate product is formed here. First the intermediate product is formed which gets further heated, as a result of which, due to the cleavage of this is a heterolytic cleavage, due to heterolytic cleavage nitrogens are formed and the nitrogen gases evolved here. Similarly you can generate the nitrogen by photolysis of isocyanate. So this is a isocyanate in presence of light. Photolysis means the breakdown of cyanate in presence of light. Lysis means breakdown. Lysis means breakdown. So here was a thermolysis means breakdown by means of heat. Here is a breakdown by means of light. So here the isocyanate gets breakdown in presence of light. That's why it's called as a photolysis of isocyanate. So here you will see that there of the cleavage of heterolytic cleavage, the electrons get shifted from this nitrogen to this carbon, and this second pi bond gets shifted to this nitrogen atom, as the result of which there is a nitrene. Alkyl nitrene is formed here, where the nitrogen is having two unshared pair of electrons. So nitrene like that of the carbene is having both singlet nitrene as well as a triplet nitrene. In singlet case, all two electron pairs are present in the same orbital, clear. But in case of triplet carbene, all the four electrons are present in different orbitals, clear. So triplet nitrene will be more stable. So we'll write that triplet nitrene will be more stable than singlet nitrene, clear here. So if you will be asked that what is the reactivity of different nitrenes or carbenes, whether singlet nitrene or triplet nitrene is more reactive, or singlet carbene or triplet carbene is more reactive. So you must remember here that if more the stability of chemical species, less is the reactivity. So here when we see the case of nitrenes, in case of nitrenes, here the triplet carbenes are more stable. It means that they are less reactive. So more reactive will be singlet nitrenes. So here in case of carbenes, the singlet carbenes will be more stable, as a result of which they will be less reactive. But singlet carbenes will be less stable, so they will be more reactive than triplet carbenes. So this was all about today's this was all about the reactive intermediates we have discussed in detail. They are short lived, they does not comes into the final product, so cannot be isolated. Clear? So their half life is very short, so that's why they cannot be isolated. Clear? So they are very reactive, which are formed during the chemical reaction. And one of the important thing is that they are important because through them we are able to determine the mechanism of the reaction. So this was all about today's topic. Hope you understand. Have a nice day.